Welcome to this episode of the Verilog Bench. Today we're going to be looking at Issue C of the AHB protocol from the RTL and verification perspective. This is the implementable reading of IHI0033C. So the emphasis here is timing, interface properties, legality rules, and the optional features that change what logic must exist. For implementation work, the first mental shift is property-driven interfaces. Issue C makes address with, data with, and optional capabilities explicit, and signals with 0 are simply absent. That means your RTL and your verification environment both have to track the configured interface instead of assuming one universal signal list. The clock and reset contract is a real design rule, not background text. Inputs are sampled on rising edges. Outputs change after the edge, and HRESP is the only active low protocol signal. Issue C also reminds you that a signal can be stable at sampling points without being guaranteed glitch-free between edges. The timing core is still the two-phase pipeline. Address and control are sampled first, data completes later, and HREADY tells both sides when the transfer is actually finished. For writes, the manager must keep data stable through weighted cycles. For reads, the subordinate only needs to provide valid data in the final completing cycle. Interconnect work lives or dies on phase-aware control. The target select lines up with the address phase, but the read data and response return in the data phase. So the select path or derive control must be retimed correctly. Otherwise, the wrong subordinate can appear to respond. Response logic is another place where simple-looking implementations fail. HREADYOUT stretches the transfer. HRESPONSE reports status, and an error response is a two-cycle response rather than a one-cycle pulse. That makes response sequencing assertions a good investment. Burst generators also need careful implementation. You have to get the increment and wrap math right. Make sure incrementing bursts do not cross a 1 kilobyte boundary and block illegal burst endings. Those are all good places for both directed tests and formal checks. Write strobes are the most visible Issue C transport feature. If the property is enabled, HSize and HADDRESS still define which lanes are active, and HWST-RB decides which of those active lanes actually write. A transfer with every strobe low is legal, and that is exactly the kind of corner case a real test bench should hit. Protection and security signals are not decorative metadata. They affect decode, downstream behavior, and what combinations are legal. So the RTL rule is simple. Treat these attributes as part of the transaction, not side notes that can drift away from the address path. Issue C makes signal validity much easier to verify because it gathers the rules in one place. Some signals are always valid, some only when HTrans is not idle, and some only during the completing data phase. The stable underscore between underscore clock property then tells you whether stable signals are also guaranteed stable between sampling edges. Exclusive transfers and atomicity are related, but they live at different layers. Exclusive signaling is a protocol mechanism that the monitor checks, while atomicity is the visibility guarantee the wider system provides. Good verification separates those concerns instead of assuming one implies the other. The last advanced topic is optional sideband behavior. Parity groups add wire-level error detection, but the spec deliberately does not force one recovery action after an error. User signals are also optional, and Issue C explicitly warns that careless use can hurt interoperability. The RTL takeaway is that Issue C gives you a much clearer implementation contract than the earlier issues. But it only helps if your design and verification flow actually follows the configure property set instead of assuming one universal interface. If this RTL deep dive was useful, like and subscribe to be notified of future videos. Next, we keep Issue C, but shift into the software and firmware view of the same protocol. AHB means Advanced High Performance Bus. AHB Lite is the single manager baseline. AHB 5 is the later capability extension layer. And RTL means the register transfer level implementation view. HREADY indicates completion or waiting. HRESPONSE reports OK or error. HSELECT is the target select signal used in decode logic, and HADDRESS is the address signal for the current transfer. HSIZE defines the transfer size. HWData is the write data bus. HRData is the read data bus, and HWST-RB is the write Strobes signal used for sparse writes. HNonSec marks non-secure traffic. HEXCL marks exclusive traffic. HEXOKAY reports whether the exclusive transfer succeeded, and stable underscore between underscore clock is the property that guarantees stable signals remain stable between sampling edges.